Hello once again, our most valued student. My name is Confident and welcome to the second session of the cubic functions, cubic graphs. And in the previous lesson, I did a similar question. If you are watching the previous lesson, I did this kind of question. Here, let me erase this. This is what we did. Now there was a question like this, and if I bring it back, we did a bit of working here on this kind of question. So if you missed it, I'll encourage you to grab hold of that previous lesson. In this particular lesson, I'm going to show you how to answer this question and take you through the processes. It's 16 marks. You can't afford to lose such easy marks in an exam. You just need the strategies, the concepts on how to approach them. So let's look at the question together. It says, sketched below are the graph of f of x. Okay, is the graph to me, is the graph of f of x is equal to this. A, they give us that coordinate A, and B are the turning points. See, this graph is cutting at A and B. The graph of f intersects the x-axis at 0 and at B. So there is a point. So the turning point is also the point of intersection. Already, these are common graphs or common questions that they ask. Now, give the value of D 1 mark. Guys, you can see that, remember when you study this, f of x is blah 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 blah, you must understand D is the y-intercept. In other words, where is the graph cutting the y-axis? The graph is cutting the y-axis. Look, there is the point. See that? So in a way, we don't have actually y is equal to 0 here. So you can see it's at origin, y is equal to 0. So the question then becomes, what is the value of D? It's simple here, just that D is equal to what? Is equal to 0. That was our cut. Alright, that's why it's 1 mark. Next question, it says what? It says here, show that the numerical value of B is equal to negative 18. 4 marks. Numerical value of B, that B. Now look at this. They gave you, when they give you information in an exam, they are giving you for a reason. So they gave us 2 coordinates, these ones, and they gave us those coordinates. So these 2 coordinates must lead us somewhere to an answer. They are giving us what? Turning point. This is TP. And when you get the turning point, you must always remind yourself, let me just work it here. You must remind yourself that TP f prime x what is equal to 0. That's the turning point concept. F prime x is equal to 0. So if I can write this thing down here to say you are given f of x is equal to 3x cubed, right, plus bx squared plus 27x. Remember, I said d 0. We can leave it like that. Now, if you are given this, and we're going to find f prime x. What is f prime x? Remember calculus. F prime x, the rules, is equal to, you take the 3, you drop it, and you subtract 1. You do the same thing, 6, you drop it, subtract 1. 27 simple becomes a 1 there. So that's what you use when you're doing the rules of calculus. So it's 3, you drop the 3, and then you've got x, 3 minus 1, it's 2. Okay, let me write it, 3 minus 1, plus b, that's not 6 please, you drop that 2, and then we've got x, 2 minus 1, plus 27, there it becomes 1. So now which is equal to 3 times 3, it's 9x squared, and then plus b times 2, it's 2bx, and then plus 27. And then we're saying this, the condition is at turning point, not the second, at turning point f prime x is equal to 0 at TP. This is a very important statement. Very important statement. That's why it justifies you then to say, therefore 9x squared plus 2bx plus 27 is equal to 0. We are justified to do that. But guess what? They gave us a coordinate. There are the coordinates. You see, they gave us A, so coordinates are x and y. So we know the x value here. X is equal to 1. You see that? Because they gave us x is 1. So we come here to say when x is equal to 1, this is happening at the turning point. So what will be the turning point? The turning point will become 9. Let's do, okay, just a moment, I'm mixing things up. So now they are saying x is equal to 1. So what is this? X is equal to 1 is part of the solution of this. Are you with me? So x is equal to 1 is part of the solution of what? Of this graph. So remember, when you solve it with the quadratic equation or with factorizing, when you solve it, one of the answers you're going to get is x is equal to 1. So if I substitute now and say 9 1 squared plus 2b 1 plus 27, since it was x is a solution, it must give me a 0 when I solve for x here. You see? So then I can simplify here and say 2b here. Now 9 plus 27 is what? I think it becomes 36 there, equal to 0. So take this to the other side, it will be 2b is equal to negative 36. You divide by 2 both sides. Remember, we're solving for x. There it is. b is equal to 36 divided by 2 is negative 18, which is what they're saying here. Look, show that the numerical value of b is equal to negative 18. They give you formats for that. Are you with me? Oh, another way maybe you could have done it is to come here and say, okay, that is it. Yeah, let's leave it like that. That was it. Now let me not complicate things. I think that was the final answer actually. Now calculate the coordinates of b. That's the next question. Here they want us to find the coordinates of b. So we've got two coordinates. We're still talking about the turning point, you see. So on the turning point, you know b is what? Is negative 18. We can continue actually this question here. Take it from here. So what you have, now you have got 9x squared plus 2, and then b is negative 18x plus 27 is equal to 0. You see that? Then you can say 9x squared minus 36x plus 27 equal to 0. And then you can see 9 is common there, so we can simply divide by 9 by 9 and by 9. And apologies guys, I think already you hear the sound in the background. There's some hushing sound in the background. It's raining, and unfortunately I wanted to bring this to you, so just pardon the rain. And if the video is poor quality, apologies for that, but I just wanted to bring this to you. So if you divide by 9, remember you divide each, it will be x squared, then into 36 is minus 4x, into 27 there is plus 3 is equal to 0. Guys, if you are not good at factorizing, please use what? Use the quadratic formula. Some of you struggle with factorizing. Don't force it. Use the quadratic formula. You know this is your a, this is your b, this is your c. You get your answer first time. Are you with me? So I'll encourage you, if you're not good, use the quadratic formula. So here it will be x minus 3 here and x minus 1, right? So x is equal to 3 or x is equal to 1. So these are the x values, but the question said what? Calculate the coordinates. Be careful, when they want coordinates, don't just leave it in x value. Now at the same time, you need to make sense now. Look at it, which x value belongs to who? Already we've got x is equal to 1, so 1 belongs to a, you see that? Then what about b? So b makes sense that 3 belongs to b, so already we know the x value here, it's 3. Now we want the y value. Are you seeing that? So this 3 here, it belongs to what? To b. Since they want the coordinates of b, now you take that x is equal to 3 to the original, the beginning of this. So you take it to the original here, and then you're going to say f of 3 into the original. It's 3 cubed. I think that. Now you know your b, it was negative 18 or what? Negative 18. Let me just check actually. No man, we don't have to calculate b there. It's 0. Look at it. It's the coordinates there. It's actually 0 there. I don't have to do this because you see it's turning at that point, which is 0. You see, so that was the answer actually. But you can well verify it, and then you put here 3 minus 18 3 squared. I'm looking at it, I'm like, this one, by the way, it was the one where the turning point is also the x-intercept. 27 3. Let's do this. You get 0 here. From the graph you can see that that point was equal to 0, so it didn't need us to calculate this, but let's just do it anyway. It's 3 cubed minus 18 3 squared plus 27 and 3. See this, equal to, we were going to get 0 there, so this was not necessary, so you can just leave it out. Okay, so now we got B. Now look at the next one. Now the analyzing of these questions is where it gets important. Now it says determine the values of value. If you think it's 1, it's fine. You see, they trick you like that. If it's a value, it's fine, but there is a chance it's more than 1. So determine the values of x for which f prime x is greater than 0. Now what is m prime x? Is the for which the derivative is positive. That's what they're saying here. If they're saying greater than 0, it means the derivative is positive. Now guys, when they're saying that derivative is positive, they are saying here, you are looking, if you have to look at it like this, let's say you're sketching a derivative. So this was your x, your y, this is your x. When you're sketching it, remember, if you sketch a derivative of a cubic, you get something like this. You get like that. This is the f prime x, where if it's on top, it means the graph was what? Was increasing. If it's at the bottom, the graph was what? Was decreasing. And on top again, the graph is what? Is increasing. So what you need to do, they are saying determine the value of x for which this graph, the derivative is greater. So you look for f prime x to be greater than 0. Look for the part where the graph is increasing. Alright, then the opposite is true. If you're looking for f prime x is less than 0, look for the graph where the graph is what? Is decreasing. So let's look for the part where the graph is increasing, and look at this. This graph, you see, you are going up. So here, when I start going up, it means I'm what? I'm increasing. So look, I'm going to be going up with the graph. I'm going up with the graph. I'm going up with the graph. At that moment, I stop. So this was going where? This was going up. You see that? It's increasing then. And then when I start going down here, this is unfortunately decreasing. So decreasing is not my part. They wanted where f of x is greater than. So at the same time, look at the other point. There is another point again. You see it? Here. From here. So I'm decreasing, I'm going down. But at that point there's a change. I start increasing again. See that? This is going up. I'm increasing, going up. I'm increasing, going up. So now, if you can look at the point, you can take the values from here and from here. Okay, let me do it. And from here. What do I mean? If you take it from here, going x going this direction and x going that direction. So you can see here it's easy. I can simply say x, there is a 3 there, remember? X is greater than 3. This is the first value. These are values of x. What about here? This is 1. So x going to the left is less than 1, because they didn't say less than or equal to. They just used, they didn't say use an equal sign, they used just a greater sign. So that's the answer. Those are the two answers here that you can put to say x is less than 1 or x is greater than 3. But sometimes for x is less than 1, you can see here you are allowed also, look, this graph here is plotted that is going, see the arrow, meaning infinity. Even on the other side it's going to infinity. So you can do it like this. You can say x is an element of, where is it starting from? Negative infinity up to 1. You see, that is the other side. It's coming wherever it's coming from. It's coming from infinity, which is negative, and it is going to end at what? It is going to end at 1. So this is the first part. Or it will start from this 3 going wherever, which is infinity. So here it's infinity, but it started from 3, so there is another part. I think that. So we can also therefore use, or x is an element of starting from 3, it goes to infinity. Don't use square brackets, use the curly one, because it's not included in that point, the 3 and 1. Alright, thank you for that. I hope it makes sense. Let's use the next one. It says calculate the x-coordinate of the point of inflection. Again, point of inflection, remember f prime prime x, the second derivative, and you at that point of inflection you must equate it to what? To 0. Very important concept. So you come here on the derivative. Where is our derivative? This was our derivative here, f prime. So if I can come here and say, let's find f prime prime x is equal to, remember we're differentiating that, which is drop 2, then you multiply, and actually I wanted the original of it. Where is it? Okay, I can't find the original of it, but it's fine. It was more like, let me just write this. F prime x was what? 9x squared. Now 2p, remember p was what? Negative 18, so it's negative 36x plus 27. This was the first derivative. Now second derivative will be what? Drop there, 9 times 2, it's 18x. 36 is minus 36 times 1. See that? Now you equate this to 0. Remember, f prime prime x is equal to 0 what? At inflection point. Are you with me? So then we are going to say what? 18x minus 36 is equal to 0. These are important points. Take this to the other side. 18x is equal to 36. Divide by 18 on both sides, and then you get your x. What is x? X is equal to 2. But the question said calculate what? Calculate the x coordinate. You don't need to go further, you leave it like that. X, they never needed y coordinate. Okay, so now you need to understand also, let me come back to this question here. When they're talking about the point of inflection, what are they saying? They're saying it's the point where the graph is changing. It's an interchange here. If that is the point of inflection, it's an interchange. Interchange between what? It's an interchange between, if I can show you here, the graph here is going concave up, you see? It's up. This is, this is concave down, because it forms a cup. This is a cup that is facing down. So it's concave down. So this is a down. Then at that interchange here, then we've got concave what? Concave up, because it's a cup that is facing up. So that point that separates that is the point of inflection, and we said at that point there is 2. Are you with me? That's what they're trying to say. And then look at the next point. It says, for which values of x, which is more than 1 already, will the graph of f be concave down? You see, they are looking about concave down. You already analyzed it. Say concave down, you see the values. So for which values of x, meaning the point of inflection you need to know so that you can know the values of x. So it starts from here going this direction, and the graph is increasing here. So you can simply write and say x going left is always less. If I'm going to the negative, remember left is negative, so x is less than 2. That is it. This graph, when x is less than 2, it will be concave down. Or you can see that this part, we say it is infinity. You can start from saying negative infinity up to 2. So this is what you write, but you just write as what? X is an element of that. So which means if they wanted the graph to be concave up this side, you're going to say x is greater than what? Greater than 2. Or you're going to say x is an element, because going to the right is greater. Element of what? Of 2, but the graph continues to what? Remember, it's increasing to infinity, so up to infinity. Those are how you analyze these graphs, and it helps you then to easily have a picture of what is happening. Guys, this was me bringing you these calculus questions. I'm going to bring 2 more going forward so that you can have an idea now. Yes, these are the standard or basic ones. I'm going to give one whereby you can sketch one from the beginning, where you are sketching a graph. They just give you the information and you need to sketch, as well as the one whereby they are giving information like these, but you find that they didn't give you A or B and C, and you have to calculate A, B, C, and then at the end of the day sketch even the graph and analyze the graphs. But these are very important for you. Remember, this follows after calculus. The moment you do dy over dx, after that these are the graphs, and then after these graphs there is the application of calculus, whereby you are calculating the maxima and the minima of applications now, where they're talking about the rates, the rate of change. I will also have a little bit of that concept. We've come to the end of our lesson. Remember, if you're not subscribed, this is the best time to subscribe so that you can be notified every time I'm posting a new video. Thank you.